Welcome back. Next, we're going to look at a book summarizer project. Now, initially, I was going to have us build this together, and it started out quite simple. But then, as I got into the nitty-gritty of making an effective summarizer, things kind of spiraled, and it became way more complicated than I initially set out to make it. So because of that, I'm not going to have us create it from scratch. I'm just going to walk through the code and sort of talk about the thought process behind how it works. So it's running right now. It is summarizing the entire contents of the book, The Great Gatsby. And it takes a bit of time. Actually, largely, it's slowed down because I added some logic in to slow it down on purpose so that we don't hit any rate limit issues. Again, I'm going to walk through how it works in a bit. I just want to show you it is running. And the core problem we have here is that every model has a maximum token context window. So I'm using 3.5 Turbo to do most of the summarization, and then I actually use GPT-4 at the end because GPT-4 is way more expensive, and I found it to be just as effective using 3.5 Turbo. Anyway, I'll talk about that strategy too, but you can see the max token is, or the context window size is 4,096. And this is not specifying, the maximum input size or the maximum output size. It's the overall context window. So the prompt plus the output tokens has to be within 4,096 tokens. Now, GPT-4 has a more expensive model that's 8,000 something tokens context window, but it's twice the price. So what we do here is we have to take a book that is very large. It's 100 something thousand tokens, I think. And we have to figure out how do we break it down and summarize it in small pieces where each request is no more than 4,096 tokens. But it's not just 4,096 input tokens, it's 4,096 tokens for the input plus the output. So we have to do a bit of work to make it actually work and function. So the strategy that I use for this is to use a recursive algorithm where we tell our algorithm to summarize the entire book. So imagine this is the whole book over here. This is like one paragraph of the book, but imagine that's the whole book, hundreds of thousands of words. When I want to summarize that whole book, that's far too big to make in a single request. I can't tell GPT 3.5 Turbo summarize this entire thing. So what I have to do is split it into a smaller piece and see if it can summarize that piece, right? And then once I get small pieces that have all been summarized, then I can join them back together in a new sort of meta summary, a summary of summaries. And I can keep going back and summarizing all these small pieces together until we get an overall summary. So I'm visualizing it here as essentially a binary tree, which is not correct. I only did this diagram here just to show that there's recursion involved, but it is not a binary tree. That implies a left and a right and only two branches. It is a tree structure. It's a recursive algorithm, so there's a tree structure involved. I'm going to walk through it, but if you're not familiar with recursion at all, it might be quite overwhelming. Let's check in on it and see if this finished up yet. Okay, it finished up. It cost me about 20 cents to summarize the entire book, although I'm actually summarizing it 3 times. I'll talk about why. So each individual summary is less than 20 cents. So let me grab the overall summary that it came up with right here, and we'll take a look at it. So this is the overall summary it came up with. Let me paste it just into a file so we can look at it. If you're not familiar with The Great Gatsby, I guess this will spoil some of it, but it's a pretty good summary, I think, if you have read it. So I don't want to read it out loud, but it's pretty good. It talks about the characters, the locations, the themes, the actual plot, infidelity, the tragic end, criminal background. It talks about the different, events and conflicts, the tension between Gatsby and Tom. And then it talks about, at the very end, spoiler, the death of Gatsby, who is found murdered, his father's pride and his son's potential, blah, 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 blah. And then it ends with the famous line with Nick reflecting on his own past. So it still adds in some, this famous line at the end. So I think it's a pretty good summary, to be honest. And we can control how long the summary is. But this is one example. So It works, but like I said, it's quite a bit more complicated than I had set out to create it, because I added some caching logic in. My request kept running into trouble, so I'm caching all the small individual summaries in a file. And that way, if one of our requests fails and we have to rerun it, we don't have to start from the beginning. We can instead just resume with however many individual summaries we had already created. And I guess I'll end by showing that it works with other books too. So I'll run it to summarize the book Peter Pan. And I'm only working with free Project Gutenberg books, which are available online. It would work with any text book if you could find one. I just wanted to steer clear of any copyright issues. So only old books at this point. Okay, so when this runs, it takes a little bit of time. I'll just fast forward to when it finishes. Okay, it finished running for Peter Pan, and let's see, it cost 39 cents this time. But again, that's actually for 3 full summaries of the book that I'm synthesizing together. So, 39 divided by 3. It's about 10 cents per summary, or a little bit more than that. Again, you get a summary here. I won't read it out loud, but we can change the length of this. But this is based on the entire contents of the book. And I think it does a pretty good job. I played around with it quite a few times and tried some different algorithms, some different approaches. And in the next few videos, I'll walk through how it works. Now, if you want to try it yourself, of course, you can just download the code. And you'll need to have, a couple of things. We use TickToken, OpenAI, use some standard libraries like Random and Time. But most of the work here is just breaking it up into small chunks, summarizing those chunks, stitching them back together as bigger summaries, and then caching anything in case our requests fail. So there's a decorator function. I'll talk about this. But basically, it's a little technical looking when you stare at it. But overall, the actual requests are quite simple. So in the next video, I'll start to walk you through how it works. I just want to demonstrate that it does, in fact, work. So we summarize Peter Pan, and we summarize all of The Great Gatsby. And it takes about 5 minutes, maybe 4 minutes. And most of that is because I've added logic in to slow it down deliberately to avoid any rate limit issues. Okay, in the next video, we'll take a look. All right, so let's talk about how the summarizer works. And before we even think about summarizing, let's just look at how we get book data. So I'm using Project Gutenberg, which includes all sorts of free transcripts of books online. So this is the transcript or the book of Peter Pan. It's just a massive text file that we can request. And there's a little bit of work we have to do because it does include at the beginning some metadata, right? Talking about the language, the character encoding, the author, the licensing, and then same thing at the bottom. So if I go all the way to the bottom, keep going, same thing here. There's the license at the bottom and some information that is not actually part of the book. So we want to get rid of that when we're doing the summarization. I mean, presumably we don't care about a summary there. And the way that I did this is that Project Gutenberg bookends the beginning and the end of the actual book content with 3 asterisks. And then, in this case, end of Peter Pan. And at the top, it has something similar where it says start of Peter Pan. 3 asterisks on either side. So the logic that I used here is pretty simple. We start by requesting the book data. So I save that in a variable called response. And you can see I tried it with Great Gatsby and Metamorphosis. So those URLs are here if you want to try them. Then I just make sure that the request worked. We got a status code of 200, and then we take the text out, and that gives us the whole complete text of the book. All of this here, including the stuff that we don't really care about when it comes to summarizing. So the next thing that I did is split the book on a regular expression where we have the 3 asterisks followed by some text followed by 3 asterisks. And so when we do that, it's going to give us 3 chunks of the book. It will split it, right? So that we have this is one chunk, and it splits right here. And then the actual book content is the second chunk. And then it does the same thing at the very end where it splits on that final little divider with the 3 asterisks. So this is specifically tuned to Project Gutenberg formatting. So if you had any text document, you would need to sort of tweak and get the data into the correct format at the beginning, where all we have is we want to isolate the book content. But whatever your book format is, what we care about is the actual content of the book. And actually, I did include the table of contents in this example. I didn't cut this out. That's fine. The algorithm can handle that. So once we have that, what we'll end up with is a list that has 3 chunks of the book. Basically, the header, the book content, and then the footer/license at the end. I'm calling it header and footer, but those aren't really book terms. It's more of a website term. So we have this list, and I'm printing it out. It's going to be hard to find, but if I scroll all the way to the beginning, here's an example when I was summarizing The Great Gatsby. This is what we see. So we have a list of 3 parts where I'm not printing out the parts, I'm printing out the length. So 818 characters at the beginning, 18,000 characters for the license at the end, and then the actual book is 270,000 characters. This is for Great Gatsby. We'll see a similar output message. There's a lot of output for Peter Pan. But the point is, we want to isolate that middle piece. So I'm then taking the element at the index of 1, which is the second part, right? We start counting at 0. So that should give us the book text itself. And so once we have the book text, we can start thinking about summarizing. Before we do a summary, I do a very simple tokenizer method call. So this is using TickToken, right, where I'm using the encode method on the encoder, and I'm passing through the entire book. Now, this is just the book content, not the header, not the footer, the license, none of that stuff, right? It's the isolated part of the book, so the text of The Great Gatsby, and this will tell us how many tokens the whole book is. The unfortunate thing is that that's not exactly the full story. It's good to know how many tokens are in the book, but we're going to have to exceed that number of tokens to summarize it, because we're going to have to make a bunch of summarization calls, and there's some overlap. And we can talk more about that later, but this will tell us how many tokens are in that book at the very least. So if I comment everything else out, we're just going to go and request the book and then print out how many tokens the whole book has. So let's do that. Let me clear my console. So this is for Peter Pan. All right. And we can see there's 73,000 tokens in this version of Peter Pan. So if we were just to take that as a rough estimate, again, it's not very accurate, but we could say, all right, if there's 73,000 tokens, and we're going to pass each of those through to our summarizer, at the bare minimum, we have to pass them through once. Then we multiply that by whatever price point we're working with. So for GPT 3.5 Turbo, I just have some logic here. It's very simple logic where I'm doing cost per token right now is $0.002, right, for 1,000 tokens. So here I am just printing out the cost per token times the total number of tokens in the book. As I said, it's not entirely accurate, but this is a good baseline to have. So I'm printing it out and then just rounding it to 2 decimal points. And let's run it for Peter Pan. And it tells me the approximate price of this summary will be on the order of 15 cents. So that's a rough estimate. So if we run it 3 times, which is what I did, that would be 45 cents. So this is actually overestimating the cost very slightly, because the actual cost was, I think, 39 cents instead of 45 cents when I ran it 3 times. We'll worry about that later. We're not going to get an exact estimate. We could. It would be a lot of work involving logarithms and some fancy math and the number e. Because we're working with a recursive function, and there's a slightly more complex relationship between the number of tokens in the book and then the number of tokens that we actually summarize and pass through to our summarizer algorithm. Anyway, we'll take a look at the logic in the next video. This is just getting the book ready, right? So we request a book, we get rid of the stuff at the top and the bottom of the book, isolate the content, and then see how many tokens that is. And that gives us a baseline for the price, but it's not entirely accurate. It's still close enough. Okay? Welcome back. The next thing I want to talk about here is some of the base summarization logic. So remember, the core problem is that we have some big book, right? That's far larger than the maximum context window for any of the models allows for. It's thousands and thousands and thousands of tokens, and the maximum tokens that we can work with is 4,096, let's say, if we're using GPT 3.5 Turbo. So we're going to have to break it up into a bunch of small pieces and summarize those smaller pieces, and then summarize the summarizations, and do that a couple of times. Okay? So the core mechanic here, the thing that makes it all work, is the summarize function. And if we look at how I'm calling this, I'm providing the whole book, right? This is what we did previously, the contents of the entire book, and then a model name, which I have in a variable. It's GPT 3.5 Turbo. And then there's this weird thing, summarization token parameters. And this is a function that I'm calling first. And the job of this function is to tell us basically how big our prompt can be and how big the summary output can be and all this other stuff based upon the context size, so 4,097, and then the summary size that we're targeting. So if we have 4,097 total tokens, right? But then we have to account for, we want to get 1,000 tokens back from the API as the output. So that leaves us with, 3,097 tokens for the input. But then we have the prompt itself, right? So this is my prompt right here. The user is asking you to summarize a book. The book is too long. You're being asked to summarize one chunk at a time. We'll talk more about the prompt. But this is some number of tokens too. So then we're going to have to subtract the prompt text size. And then that will tell us how many tokens we can actually pass from the book itself each time through. So let's say that returns to us, 2,500 tokens. That's our number that we get back from this function here. It says every time that you try and call summarize, you have 2,500 tokens of the actual book that you can provide. So that's where that math, we'll take a look at the function, but that's why there is math, because we have to account for the overall context window size, the size of the output, that's subtracted from the context window. So the summarization itself, then the size of the actual prompt, the words that we write to instruct it, then that will tell us, the difference between all that will tell us how many tokens we actually have allotted for the book text. And if we take a look at this summarization token parameters, it's up here, right here. It expects a target summary size and the total context size for the model. And then the first line in here is it's going to figure out how big the base prompt is. And this is calling our summarization prompt messages. This is the function called summarization prompt messages right here. This is what generates the actual prompt text. So it's what I just showed you. It basically just takes the base summary and passes it to this num tokens from messages function, which is what we saw previously. Where is that? This is straight from OpenAI's tick token lecture, where it talks about how to calculate the number of tokens in messages. So this will return to us the number of tokens in our prompt, just the base prompt, the text that I've written right here. Okay, so when we have that, then the next step is to use that base prompt size and subtract that from the model context size, but we're also going to subtract the target summary size, which is what was passed in. So it's this equation that I showed you down here. It's hardly an equation, but it's this process right here. Whatever the prompt text size is, that's what we just calculated in that function. Our desired output size of the summary, what I'm calling target summary size, and then the model context size. So this function just returns to us, it actually returns two values. I'm using some typing annotations in Python. You don't have to do this, but you can see it returns something of type summarization parameters, and you can see I've defined summarization parameters up here. This is just a way of setting out a strict set of rules for what data should look like, the shapes of data. So for something to be summarization parameters of that type, it has to have a target summary size and then our summary input size. And summary input size is that's the most important part. That tells us how many tokens we have left when we provide the actual book content to each request. So it's a lot of work just to figure that out. I mean, it's basic math, but you have to think about it. So once we know how many tokens that is, it's returned as a summarization parameters, and it's called specifically summary input size. This is how much of the book we can pass each time through. And target summary size is the overall end resulting size for the output that we want. Each summary should be 1,000 tokens, or each summary should be 500 tokens. I'm calling it down here, right here, with a target summary size of 1,000 tokens. Okay, so this is just returning to us those two numbers. So it takes the context size and our target summary size. It does the math to figure out how much space we actually have to pass the book through each time. And then we provide a division point. And this part's also important. Let's say we find out we can use 2,500 tokens. That's how much space we have for the book. And let's say 2,500 tokens goes like up to there, although that's actually going to be far less than 2,500, but just suppose it stops on the letter M. Well, that's not ideal when it comes to summarizing, because the next time through, our summarization will start here at 2,500 tokens. And it probably can figure some stuff out, it will omit some information, but there's a chance that it splits on a really important word or in the middle of a critical sentence, and that will be lost. So instead, the logic I've written says, we want to try and get, let's say, 2,500 tokens, the maximum that we can fit, but I don't want you to split in the middle of the word. I want you to make sure to stop at a period or whatever your division point is that you provide. So I'm using a period. It's just a simple way. You can see right here, division point is a dot or a period. We pass that through. And now we'll look at the summarized logic in a moment. It will try and split. It will take the correct number of tokens up to a period. So it will make sure to stop on a period and try and take as much as it can out of that 2,500. The alternative is just to say, take 2,500 every time, and who cares where you split? Or an even fancier version would be to try and split on chapters, new line characters for paragraphs. Depending on the book that you're working with, there's different signifiers, to show that there's a new chapter or a section. There might be asterisks. There might be some regular expression you could write to look for the word chapter. And that would be great if we could summarize one chapter at a time, but that's too specific to individual books, because a lot of books have very long chapters where that wouldn't work. We would hit our max token limit. Anyway, all of this video is to say that there's some work that goes into figuring out how much of a book we can actually summarize at any given point, because we have to account for not just the amount of the book, but the prompt base text. This takes up tokens. The output, target summary size, takes up tokens. And then we have to consider the overall model context size. There's a hard limit. So once we have those numbers and we have the division point, the model name, and the book, in the next video, we'll walk through what actually happens in the summarize function. All right, let's carry on with the summarization logic. So we have our summarize function. We call it with our text initially the entire book, which is what I did down here. All right, we pass in right here the entire contents of The Great Gatsby or of Peter Pan. And then we pass in the result of this summarization token parameters, which basically just says, it calculates, we saw in the previous video, how many tokens we have available for the actual book content in every prompt. And then a division point, which I'm using a period for, and then the name of the model, which I defined, I think, way at the top somewhere. It's just GPT 3.5 somewhere. Anyway, inside of the function body, I have some logging. This has nothing to do with the summarization. It's just generating output. So when I run it, we see, where's my terminal? Things like summarizing this amount of token text, and then a little preview of the text. Summarizing this amount of, it just shows me what's happening. So it has nothing to do with the actual summarization. This is the crux of the summarization. So initially, we're going to pass in a full book. And the first conditional here, there's 3 branches. The first conditional checks to see, is this piece of text shorter than the target summary size? And in my example where I called summarize, I passed in the target summary size as 1,000 tokens. So that's my end summary goal. I want a 1,000 token summary. So our first conditional checks to see, is this text smaller than 1,000 tokens? Right, it's using the encode method. Remember, this is what we saw previously from TickToken. This tells us how many tokens are available or are in this piece of text. Now we know when I passed through the book initially, this is not going to be true. So then the second piece checks to see, all right, well, what about, is this number of tokens in this text smaller than or equal to the space we have allowed in a single prompt? Is it less than or equal to, in my case, it's like 3,000 tokens or something? Will it fit in this number that we calculated? Remember, this number is calculated based upon the context window size subtracted by the prompt number of tokens subtracted by the actual number of output tokens that we want. So it's checking to see, is this small enough to fit in a single request? And if it were, then we simply run GPT summarize, which is a method we'll look at soon. And in our case, it is not small enough, right? If it's the initial book passed in initially at the beginning, it's way too big to fit into a single request. So that's where the else comes in. And the else is the most complex part. What we do is we split the text into a bunch of sections. We split it into sections that are of some size based on the summary input size. So we have a method called split text into sections. It's in the utilities file. It is right here. It takes a piece of text, it takes the maximum token quantity, it takes a division point, which for us is a period, and then it takes the model. And what it does is it divides this big piece of text into a bunch of smaller sections that are at most max token quantity tokens long. And it aims to split them along the division point. So in this case, we're passing through, when I executed it, the period as the division point. And then our summary input size, let's call it 3,000 tokens. It's going to try and split the entire book, which is what happens the very first time it's called, into a bunch of pieces that are 3,000 tokens or smaller, and they're split naturally on a period. We could have written it to divide it exactly into 3,000 token pieces, but then as I mentioned, we would probably almost certainly end up with words being split, let alone sentences. So by using the period, it's a way of at least getting some sort of logical endpoint for each chunk. So you can look at this function. It's relatively straightforward. It calls another function called take tokens. And this take tokens function is a little more complex, but it's the function that gives us, given a piece of text, it will give us 3,000 tokens of that text, or 5,000 or 2,000, and strive to divide on a division point. And it is right here. So it's a little bit more complicated. This is take tokens. I don't want to spend too much going over it. I've commented it pretty well, I think. So it uses tick token, right? Because we have to know how many tokens are in our piece of text. And then we split it on the division point. So we split it on a period, and then we try and get as many of those split sections to add up to 3,000 tokens, or whatever the max token quantity is. So there's some logic in here. It's nothing terribly complicated, but basically we accumulate as much text as possible while ending on a period. And then we do that over and over and over, and we build out this list called sections, and we return sections. So sections is going to be a massive list with a huge chunk of, let's call it 3,000 tokens that ends on a period, or as close to 3,000 as we can get. And then each one of these can be summarized. Okay, so when that finishes, if we go back to summarize, we get this split input that has all of the different small pieces of the book. The next step is to call summarize on each one of those pieces. So we have some recursion here. So each individual piece will be summarized. And when each of them is summarized, they should be smaller than the summary input size. So at that point, we actually call the GPT summarize method on each one of those small individual chunks that are split on a period. And GPT summarize is what actually makes the request. And it is right here. And GPT summarize is a little complicated only because I'm trying to manage rate limit and error issues. But at its core, it's simple. It's making a completion call, or a chat completion rather, where we pass through some messages. And I created a method, right? Summarization prompt messages. If you look at the prompt messages function, it's this one right here. It takes a piece of text and this text is going to be smaller than our maximum size that we allowed, and then it takes that target summary size so that we can plug it in right here. And if you look at the prompt, there's kind of a lot going on. There's the basic part that just says, we want you to summarize a book. The book is too long. You're being asked to summarize it one chunk at a time. And then this part is a little tricky. It says, if a chunk contains a section surrounded by 3 square brackets, such as this, then the content enclosed is itself a GPT-generated summary of another larger chunk. Weigh such summaries with greater significance than ordinary text. And I'll talk about that piece and why I added that in a bit. But notice down here, we tell it, strive to make your summary as detailed as possible while remaining under, this will be 1,000 token limit, whatever the limit is for that summary size. And then at the end, we tell it summarize the following text. And that's the actual chunk of text from the book. Okay, so we return that list of messages from here and we call it, right? This is what's actually making the API call. And there's some logic in here to try 3 times at most if something goes wrong for each request. And then you'll see, we are accepting certain errors. I'm adding in a random sleep time, so it waits between 1 and 5 seconds. If the initial request, if we hit a rate limit error, then we wait and we try again. So there's some logic to slow it down and pick a random number of seconds to wait, just because if you don't delay it at all, I kept hitting rate limit issues. Okay, but let's just assume it works. So we ask it to summarize the first chunk of text. Let's just say it's this chunk of text right here. When it returns back its summary, notice what we're doing is wrapping it in those triple braces. And the reason I had to do this, imagine this is a whole book. If I asked it to summarize this chunk, and it summarizes it, and then summarize this chunk, and it summarizes that, and it summarizes this chunk, and maybe now it's able to summarize all of this together because it's smaller now, right? This is a small piece, small piece, small piece. It can summarize it all together. What was happening is that the model wasn't treating these earlier summaries as important. It was basically treating them like any other sentence. So if I reduce this down, 10 paragraphs down to a single, let's say 3 sentences, and then it has to summarize that with a whole bunch of other text, it doesn't treat the smaller summary that I made at the beginning with enough reverence. It sort of ignores it. So that's where this prompt comes in. I tell it, if you see text wrapped in triple braces, I just picked some symbol that was unlikely to come up in the actual book. If you see something wrapped in triple braces, this means it's already a summary that you generated earlier, and you should treat it with more respect than something, similarly sized. So this tells you this is a summary already that you've made. I keep saying you, but this is a summary that the model has made. And so it knows that this is important. And a single sentence in there might have been generated from, paragraphs and paragraphs of text. So that's why we wrap the result from the API call in these triple braces. All right, so if we go back to the summarize method, or the summarize function, right, it gets all these summaries, it returns each one, and then if we go back to the initial recursive call, each summarize call is going to be added to a list called summaries, and then at the end, when all those individual summaries have been returned into this list, we call summarize on that overall list joined together. So all the smaller summaries joined together into a bigger paragraph or multiple paragraphs, and then we summarize that. And if it needs to, call itself again and again, it will. It's a recursive function. So I illustrated it as this binary tree. It is not at all a binary tree, but it is a branching tree structure. It's just not a nice and neat binary tree. And that's pretty much it for the summarize logic. I mean, there's a lot there. It's a little hard to understand, especially if you have no experience with recursion. This probably made no sense at all, but trust that it does work. And what makes it hard is having this maximum limit for the overall context window of how big the prompt plus the output can be. So we have this limitation. And then of course a book is way bigger than that. So we're going to have to split that book up into a bunch of small pieces, summarize them individually, and then join those small summaries together. That's what's happening right here, and re-summarize them. And then that itself, those joined summaries together might be too big. So they'll be split and generated into smaller summaries potentially. And then the final step is this summarize method will return a chunk of text that does have these angle or the square brackets on either side, indicating that it's a summary generated by ChatGPT or by the API. And so we want to remove those when we output the results. So let's call this like overall, or I don't know, summary. And then I can print the summary. Okay. And let's check it out. I'm going to run this in my terminal. Oops, not ls. And it's going to take a while. In the next video, I'm going to talk about the caching side of things if you're curious. But if all you care about is the OpenAI side of things, then we've covered all of that at this point. There is one other detail that I will cover in a future video, where I actually generate 3 separate summaries and then have GPT-4 synthesize them together into an overall summary. But let me just let this finish and show you the end result. All right, it finished up. And if you notice, every time it says summarizing this amount of tokens, summarizing this amount of tokens, summarizing this amount of tokens, and then it shows a little preview of what it's summarizing, right? It's just the first couple of characters, and then it adds a ... So first of all, you'll see that at the end, it's summarizing a 4,500 token piece of text, and that's way too big. Well, it's not way too big, but that's too big for the context window. So it has to be split again. It's already a meta summary, right? So it's creating a summary of summaries. If you see those brackets there, it means this is already a summary we got back. So it splits that into a couple of pieces, and then finally it finishes. And here is our final summary right here, down to here. Okay, so in the next video, I'll talk about how it caches things, because that can come in handy. It often, it's such a long request cycle. It can take, 5 minutes or more for this to finish. And if something happens, if the API slows down, it goes down, if your computer shuts off, you don't want to have to, go through the whole process again. So I'll talk about how to cache it next. Okay, next I'd like to talk about the caching logic. So if you notice, and I've already mentioned this, when we call summarize, there is this memoize to file decorator that is decorating this function. And what this decorator does is, if we look at it in utilities, it basically takes the contents, you can see right here, it decorates the output of a method and saves it to a JSON file. And this JSON file will just have a record of every input that we tried to summarize and every output that we got, every summary that we got back. So it's simple enough. Basically, it looks to see if there's a file that already exists with our cache. I'm just calling it cache.json as the default. And if it finds that file, then it loads the contents as cache. Otherwise, cache starts as an empty dictionary. And then what we do is we take the arguments to summarize, all these arguments, we hash them using just a SHA-256 hash. Basically, we'll end up with a big hash looking thing, like something like that, in quotes, a bunch of gibberish, but it's the unique hash of the arguments that we pass through. So whatever those arguments are, they will be hashed, and that will just be used as a unique key. And then we'll take that hash, and under that hash, we'll store the result of executing the function, the summary in our case. It's a decorator, so it's a generic func, but the summary will be cached in a file under the key of arg hash. So if you look at the cache file that was actually created for us last time I ran this, it looks something like this, where, go away, we have this unique SHA-256 hash, and then the contents of that, so the arguments that generated this summary were hashed. This is the unique SHA hash, and then this is the value. And so this is all over the place in here. It's a very long file, storing all of the summaries and the hash of the arguments that gave us that summary. And the reason that this matters is because if we've already summarized something, right? If we've already summarized, let's say, text is the entire book, token quantities is, the same values, the division point is a period, model name is 3.5 turbo. If everything's the same, we'll get the same hash when we call this line right here. And if we get the same hash, there's some logic to see if it's already in there. Is that argument hash already in the cache? If it is, let's return that. And then that prevents us from having to actually re-summarize. So I'll show an example of this. If I rerun my code that just took 5 minutes to summarize all of this stuff from Peter Pan, it immediately finds it. And this is completely wrong now, the price. It didn't actually charge us anything because we didn't even make a single request. What happened is that it took all of the arguments to summarize, it hashed them, and it realized that it already found a cache result for that value in the cache file. Now, as soon as I delete that, I delete the cache file, then it's going to do the whole process over again. So let me just show that. Let me show it like if I stop it halfway through. So I'm going to delete my cache.json file. Okay, and then I'm going to re-summarize. And then you can see I'm printing out cache not found every time it doesn't find the cache. You really don't need to have that. We can clean that up. It's just showing it's not going to find anything in the cache because nothing has been cached. But now if my cat walks on the keyboard and stops, let's pretend that it was almost done. In reality, we were very early on. Now if I summarize again, it's going to find the first couple of summaries that it needed in our cache. And you'll see cache result found, cache result found, cache result found, and then it doesn't find the remaining summaries, so then it has to actually get back to work and make requests. So it's adding to our JSON file as it makes new summaries, and then it stores them there. So in case it gets interrupted again, it can go and find them and not have to make that request from scratch. Okay, now if you're not familiar with decorators or hashing, I mean, this is overwhelming. It has nothing to do with OpenAI. It's just a nice little helper function, basically, that we can throw on top of any other function and cache the output of that function. So I actually use it in another place, which is right here. In the next video, I'm going to talk about this synthesize summaries function, and then we'll be done. All right, so we're almost done walking through the summarizer code. The final piece I want to talk about is this bit of logic down at the bottom I've had commented out. So what I found is that by using GPT 3.5 Turbo, I got pretty good summaries, and it's far cheaper than using GPT-4. It's way, way cheaper, and it's good enough. But what I found worked really well is if I actually generated 3 or more summaries from a lower model like 3.5 Turbo, and then I pass those through to GPT-4 and tell it to combine them. It gave me a pretty good end result. It was a higher quality end result without having to use GPT-4 for all of the summaries. So right here is some logic where I'm going to summarize the same book 3 different times, where I specify a different summary size that I want it to generate. A 500 token summary, a 750 token, and a 1000 token summary. And it adds them all to a dictionary. So if I just show this right here, I'm going to run it. It's going to take a while. Let's print out our summaries. Okay, so I start with this empty dictionary. And then I have my 3 sizes. And for each one of those sizes, I'm going to call summarize and pass through that size. So summarize the whole book as a 500 token summary, and then store that in my summaries dictionary, and then do the same thing for 750 and the same thing for 1000. So I'm going to get rid of this line because this is doing a single summary. Okay, so I'm going to start this now, and it should find some stuff in the cache eventually because I already did a summary at 1000 tokens for the summary size, right? That's what we had been doing up here. So it should find that. However, it has not summarized Peter Pan at 500 and 750 tokens. So it's going to do that now. It's going to take a while. So I will edit this and be back when those 3 summaries finish. And we won't have an overall meta summary yet. We're just getting our 3 individual summaries. And then the next step is when those are done, I'm going to pass them through to a function called synthesize summaries, which is up here. And synthesize summaries is also memoized, so it's just cached to a file, just so we don't have to, if I've already summarized this book, Peter Pan, and done the mega synthesis, no reason to do it again. Just take a look in the cache file. Okay, so it takes a list of summaries, and then all that it does is it creates this messages list, right where it says a less powerful GPT model generated some number of summaries of a book, however many we pass in. Because of the way that the summaries are generated, they may not be perfect. Please review them and synthesize them into a single, more detailed summary that you think is best. And then here are the summaries. So we join them together, and then we pass those messages through, create a new chat completion. And when I call this down here, I'm using GPT-4. That's kind of the whole point, to use the better model to do this overall summary. So this is still going, of course. It's doing a whole bunch of summarization, 500 token summary, a 750 token summary, and a 1000 token summary. And then we'll get them all back. And then I'll be able to rerun this again, and it will find the cached results. And then I can finally get my synthesized summary. So that's the final piece. I'll be back. Okay, so finished up. You can see I've got a dictionary now that has a 500 token summary, a 750 token summary, and a 1000 token summary. And of course, you could change that number, right? Just remember, the longer the summary that you're trying to generate, the more calls it can take, the more API calls, because you have less space in each call in that context window to provide the actual book. Now that we have those three summaries, we can now call our synthesize summaries with those summaries. So I'm just going to take the values out. So I don't care about the 500, the 700 key. I just want the actual text. I'll take those pieces of text and pass them through into a new list to synthesize summaries. And synthesize summaries, we already talked about. It's right here. It takes all those and it adds them in to a single prompt saying, please generate a better summary. And we'll use GPT-4, a better summary to synthesize these three smaller summaries. And then it returns that. Okay? So I'm passing that through, and I'm going to rerun this whole thing again. But unless the book has changed, which is possible, the text could change, I guess. But assuming that hasn't changed and I have the same lengths here, I'm not going to have to re-summarize anything. It's going to go and find them in our cache, as you'll see right here. It should be very quick. It will find our three summaries that already exist. And then it doesn't find the final mega summary right here because it hasn't been cached yet. So this is the only summarization it has to do at the end. Take our three overall summaries right here and synthesize a single summary. And it finished up. And here is our overall mega summary. Starts here and it ends here. And we probably should format it nicer or print it out or, do something so you can see it. But this is the overall synthesized summary. And I think it does a pretty good job. Peter and Wendy by J.M. Barrie follows the adventures of Wendy Darling and her brothers John and Michael as they travel to Neverland with Peter Pan, the boy who never grows up. In Neverland, they encounter pirates, mermaids, magical creatures, and the Lost Boys. Throughout the story, the struggles of motherhood and eternal youth of childhood are highlighted. After adventures, Peter returns Wendy and the Lost Boys home, where their parents decide to adopt the Lost Boys. Peter, however, chooses not to stay and continues his life in Neverland. As Wendy grows older, she recounts her adventures to her daughter Jane, who eventually meets Peter and flies with him to Neverland. The story suggests that Peter will continue to visit and take future generations of children to Neverland as long as they remain innocent, symbolizing the cycle of growing up and moving on. Decent enough summary. And yep, we could totally specify a different length, right? We could get a longer summary if we wanted to. It's just that we have that limitation of the amount of text we can provide versus the amount of text we can get out. And that is it for the summarizer. So there's a lot of code here, right? It's a lot of recursive, I won't say nonsense, but tricky recursive calls if you're not familiar with recursion. There's some fancy things like a decorator in there to cache the results that we've already gotten, so we don't have to make a bunch of unnecessary requests. And we use TickToken quite a bit. Not really to estimate costs, but more so to make sure that we can fit our messages into a single context window, to encode a string and see if it's big enough, or small enough rather, to fit within our prompt. Okay? And that's pretty much it. So I'm sure it's confusing. I'm sure you'll have questions, but play around with it and see if you can improve it, by the way. There are many better ways we could summarize things, including trying to summarize entire chapters of a book. That would be the best approach, right? Instead of just splitting on a period, which is better than nothing. It would be nice to get a whole chapter at a time if each chapter could fit into an individual request. And if not, maybe it still would be a good strategy to summarize each chapter individually, break that into pieces if necessary, then get all the individual chapters and then stitch those chapters back together. So some more complex logic you definitely could add in, but that's it for now. So GPT 3.5 does the bulk of the lifting here, and then at the very end, we come in with GPT 4 and stitch together 3 summaries. And you could add more in too, right, of a different length. That's it.